Hello everyone. So today we are going to learn about another very useful transformation that we are calling it as a normalizer transformation. So normalizer transformation is mainly used whenever we want to represent the data, again the organization data in the right fashion. Uh, that time we rely mainly on this transformation. This transformation has a capability to transpose the data or slice and dice the data in different formats. So for example, all the column data can be transposed to the row data or vice versa. So that is what the capability of this normalizer transformation. Uh, if I take an analogy of this, then I will go with the transpose function, which we all have seen in Excel sheet. So if I want to show you that, so if I open an Excel sheet and my data is something like this, so Jan, Feb, so let's say every month there is some data available to me, and let's say I have 3 months data, or rather 4 months data, and this data I want to present in a column wise manner. So I can copy this and I can paste it using a transpose option. So if I do a paste spatial, there is a transpose function available. If you click on this and say OK, you can see that this particular data, which was earlier row based data, so every row was having the months, now that same data got transposed into columns. So the data is now changed in a different format. So that is the same analogy which we can apply whenever we want our data to be transposed between row to column or column to row. So that is what we can use using the transpose or rather normalizer transformation. So considering this example, you can see that I am going to read the data. So so the data which is coming in is, in this example it is 4, and the data going out in this example is only 1. So these all are the column names. So that means this is actually an active transformation, because the number of rows going out is not equal to the number of rows coming in, and this particular transformation has to be used in a connected fashion. So what example I'm going to show you is, let's say I have the input file looks something like this. So let's say this is my input file, which is having store name, sales for quarter 1, sales for quarter 2, sales for quarter 3, and sales for quarter 4. So here my store name is unique, and for each particular store I am showcasing the sales for the 4 quarters as the value for each column. And as an output, I am going to expect the value should come something like this. So if I depict the same source file, I am going to have the data something like this. So it will have store name, quarter, and sales. So store name in this example is going to be again store 1 for quarter 1. Sales is 1000. Store 1 will have 4 entries for quarter 2, for quarter 3, and for quarter 4. It will be 2000, 3000, and 4000. And for store 2, the values are 1500, 2500, 3500, and 4500. So the output will look something like this. For store 2, again the values for quarter will be 1, 2, 3, 4, and the output is going to be 1500, 2500, 3500, and 4500. So that is the expected output for this particular transformation, and for this I am going to use the normalizer transformation. So I have already created this, or rather imported the same flat file which I was showcasing you here, and based on this you can see the store name and 4 columns for sales Q1, sales Q2, sales Q3, and sales Q4 got imported. I'm closing this for now. I am going to create the target based on the same flat file, that is ff_sales. So let me rename this quickly. So let me name this as normalizer trans example. It is a flat file. I am going to change the columns as it is going to have, let's say, only this will become sales for me, and there will be something called quarter, and I don't want these last two ports, so let me get rid of this. Sales, again it has to be the number value, so I am keeping the sales value with the precision, let's say something in more. Store name I am keeping it same, let me increase the precision for this. Quarter, it has to be the number, let me keep the same thing. Apply this, say OK, save this. Now come to the mapping and quickly create a mapping. Normalizer transformation example, that's the name I am giving. I am pulling the source, that the file which I just showed you, and the target which I created just now. Now to transpose the values, I already have told you that I'm going to use the normalizer transformation. So let's create that normalizer transformation using the transformation drop down menu. NRM is the prefix which I use for normalizer transformation. Let me name this as sales for store name. By default, it creates a blank transformation. If you open this transformation, you can see again the first transformation tab will have same as you have seen for any other transformations. Port, you cannot come and create any kind of port on this transformation, so all the actions are disabled. Properties, it has 3 properties apart from tracing level, which we have seen in all the transformation. It has 2 properties called reset and restart. We will understand what these properties in a while. Normalizer is the place where you have to actually create the column names and the occurrences of each columns based on which you want to make the transpose functionality. So for this, I'm going to create 2 ports now, and let me name this as, if you see, I am going to have one store name. So I'm creating one port as store underscore name. This will be a string of value, let's say 10. And the second one is quarter. If you if you have seen, my expectation is for one store name there will be 4 quarters. So for that reason I am creating this particular quarter with occurrence as 4. Let's keep it as number 10. Now based on this value, if I come back again on ports tab, you can see that automatically for this particular store name and quarter, which are turned as the output parameter, there is similar name with underscore input as the port for input port. So for store name whose occurrence was 0 here, I can see there is one port got created which is of the same data type, and for QTR whose number of occurrences I have mentioned as 4, I can see there are 4 ports. Input ports got created as I underscore IN1, IN2, IN3 and IN4, and the data type of this is same as what we have given for QTR, which is an output port. Apart from these ports, automatically this transformation creates 2 extra ports, that is GK and GCID. So whatever port you are making the number of occurrences, anything which is more than 0, system automatically takes that particular port and assigns 2 values to that particular port. One is GK and another is GCID. GK stands for the generated key, and the generated key value will start from the sequence number what I have seen in this sequence column. By default it is taken from 1 and you are not supposed to change this. So this is the generated key, and for every record it will keep on incrementing this sequence and process the transaction data. GCID is majorly meant for generated column identifier. So the column identifier for that particular port whose number of occurrences is more than 1. So these are the 2 default ports which gets created in normalizer transformation. And now if you come to the properties tab, you can see that this reset and restart property got enabled. So reset property stands for once the session ends, I want to reset the value for generated key sequence back to 1. So if you see, if I don't make any change, this 1 will keep on incrementing after the session execution, and if I do not set this property for reset as on, then it will keep the value as the value which will be taken at the end of the session. So that's the reason I am ticking on this reset option. And restart actually talks that the generated key sequence value will again need to be start from 1. So that is the restart option is. So I'm keeping both as checked. Apply this, say OK. Now with this transformation, store name I am going to push as it is. All the sales per quarter I am going to push this values to the 4 quarter input. Actually, I have given a wrong name, so let me correct this because that will cause confusion. So this is not actually a quarter. This is actually a sales value. So once I change this, if I come here, you can see everything is actually sales underscore IN1, IN2. So I mapped my sales of each quarter to the sales of 4 input. So these are nothing but my 4 occurrences for sales field. Now when I want to populate my output target, again store name, which is my output port, I am linking this with the store name. Sales, I am linking it with sales, and the quarter I am going to select the GCID as one of the port. So again, if I rephrase the GCID significance, it is nothing but the generated column identifier for that column whose number of occurrences is more than 1. So I am going to select this for the quarter. Will not use this particular output port for now. If I have used this, then it would have taken all as 1, 2, 3, 4, 5, 6, 7, 8. We'll see that. For now, I'm not connecting this at all. Save this. Quickly create a workflow for this particular mapping. Open the workflow manager. And if you see, I have just now created this SQL this is the example I have just created. Just come here. There is no need of giving the value for source and target because I am using both as flat files. Come to the mapping. Here I am going to use the file location for my input source file as this. And the input file name is same. Let me keep the same thing. And I'm going to create the output file at this location. So let me give this path here as the output file directory. And my output file, let's say I want to get this as a CSV file. In this session task level, you actually cannot override this reset and restart property. You can only change the tracing level. So I'm not changing it as of now. Save this. And when I re-execute this particular workflow, so it shows that my task got succeeded, and based on that, my workflow is also successful. Let me go to this target file. So you can see my output file got created. Let me open this. So you can see that for store 1, it automatically took the values based on the quarter. And here the quarter is placed as 1, 2, 3, 4. And again, it is 1, 2, 3, 4. So that is the significance of the port called GCID, which is generated column identifier. Assume that if I have used the other port, so let me quickly show this again to you. So I am going to change the column and I'm going to add a new column, and let me name this as QTR underscore GK. It's again a number of precision, let's say 4. If I save this and I link this GK port to the QTR underscore GK, save this, come here and rephrase this mapping once, save this. Let me quickly delete this particular output port so that I can show you how the new output file will look like. So again, this is my own file, so I'm going to delete this file for now. And I'm going to re-execute this particular session task. Now if I go and open this target file, which I created again because I had deleted earlier, now you can see the last port, which is nothing but my GK ID. It is having the incrementing value starting from 1 till whatever session executions happen. So for each execution, it kept on incrementing that value, while the GCID is nothing but the generated column identifier based on the port on which the number of occurrence is made more than 1. that's how this normalizer transformation works. I hope this video is useful to you. If you have any questions, feel free to add your questions in the comment area. I will get back to you. Thank you.